Hello and welcome to the session about Headless Drupal, the Gizra way. I am David Hernández. I obviously work for Gizra. If you don't know, it's an Israeli company, mostly known for organic groups and some other modules. And in our day-to-day, we mostly do Drupal, but half the time we don't do the standard Drupal. We do Headless Drupal. For those who don't know what's Headless Drupal, it means we use only Drupal for the backend while we create the application, JavaScript application that communicates with the backend. This helps us because it allows us to do more flexible application and a quicker development for some specific cases. Before starting, I'm going to follow this small index. First, I will talk about the backend, then about the frontend, and then I will show how do we integrate with real-time notifications. All this session is based on a workshop I did with a workmate on Drupal Dev Day Seville. That it was 2 hours workshop, and this is a 1 hour session, so there is going to be a lot of content. I have to remove some content, but you can find the code for all the examples in this repository here. I will tweet it later. So no, let's not waste time, and let's start with the backend. RESTful is a way of communication between a provider, in this case Drupal, and a consumer, normally a JavaScript application, but it could be a mobile phone or whatever. And we use several fundamental operations that are part of the HTTP protocol: get, post, delete, patch, put. We use the RESTful module. This is still Drupal 7. I will not talk about Drupal 8. For us, Drupal 8 we think is not ready for this kind of applications yet. We are still waiting for some changes on the JSON API module, but hopefully it will be ready soon. The module is maintained by Amitai Burstein from Gizra and Mateo Aguiló from Lulabot. And those are some of the main points, main focus points of the module. It tries to avoid Drupalism. That means in the output you will not see like fill, language known, multiple nested arrays. That's not what you expect on this module. It supports versioning, so you could have like multiple versions of the same endpoint. You also support multiple formats. You can put like a JSON output or a XML output or other options. And it's also built for developers. So it's not, by default, it doesn't do too much. You have to write your own code to make it work. And then, when we are consuming an application, we need a way to authenticate the users, so they don't get so every person doesn't get all the content, because some content is restricted for some users. So we need to find a way of authentication. The module itself comes with a couple options, and it also allows us to write our own authentication methods. In this case, we are going to use only the access token. And an access token is just a string that contains some odd characters and composed by numbers and letters that represents a user in the system. And the first request we do once we authenticate is to get this token. We keep it on the application, and then we use it in every request to the backend to identify the user. And this is how it works. You just do HTTP get, the URL, and send a header, authorization basic, and encode on base64, username, password, and that's it. And you get something like this. You have the access token, you know when it expires, and then you use that access token everywhere. So let's see some code. RESTful module uses ctools. So every endpoint is a ctools plugin. And the first thing you have to do when you write a ctools plugin is to write this hook, ctools plugin directory, where you specify where all the code is located. That's it. This is more or less the structure your module will have. This is inside your module folder, so it will be something like whatever, then plugins, RESTful. And this is optional. You don't have to have this structure, but we encourage you to use it. So it's all better structure, and you know everything where it is. You don't need to have the node folder, you don't have the board, the message version. So the application I'm going to show you is a use case we wrote for the workshop on Drupal Dev Days. It's a chat room where the users can create rooms and can send messages, and those messages are broadcasted to all the people connected. So we will have only two entities, the board and the board messages. So for each endpoint, you just need two files, the definition of the plugin and the implementation that we will see now. This is how you define a plugin, something simple. You have a name, a human readable name, resource that it will be the URL you use, the name to identify the resource, what entity type is using. It can be a node, it can be a user, it could be a file. The bundle, in this case is a board, a human readable description, and then the class we are using. We also specify if we are, in this endpoint requires authentication. This is the content you put on the inc file, in this case here. This file could be named anything. You don't need to specify the version here. And then we start with implementation of the class. The RESTful modules give us a lot of different classes to start to extend our plugins that will help us a lot. It will give us a lot of content. In this case, we are using the RESTful entity base node that we extend. And then we define which fields we want to have on this endpoint. In this case, we call the parent function to get the standard fields present in each node. These are the IDs, the titles, and that's it. And then we add the fields we want. First, we add a description that references the property body. And as we want to avoid the Drupalism, we specify the subproperty. We want only the value. We don't want the full array containing the language, the value, the input format, and all the different data that is stored in a field. In this way, our endpoint, we want to say description and the value of it. We can also specify custom callbacks. So we return anything we want. And this is a function that we create. We can customize, and so on and so on. And if we want to modify an existing field, changing some things, we can specify a process callback like this. Here we have the author that references the property author, in this case the node author. And then we specify the process callback, a custom author. And we will see how these functions are implemented. In this case, when we use a callback for a dummy field that we can return anything, we receive an entity wrapper, a metadata wrapper, and with the full node, and we can work with it and return anything we want. The process callback is quite similar. Instead of the wrapper, we receive the full node object. And in this case, the only thing we do is, if we are the author of the node, we'll return you instead of the author name. This is super simple, super quick, and with just those few lines, you have a full endpoint, RESTful endpoint. This means you get all the items, you can filter by fields, you can access individual items, you can post to create new ones, you can update, you can delete, and you have done it in just a few minutes. So it's a super quick way to develop and to create RESTful endpoints. This is the second endpoint we will use. I will not get into details because we already know this. And this is the implementation of the fields. Here, there is a little difference. In this case, we are referencing the other endpoint we created before, the boards in the board message. So we are talking about the field board reference field, and we specify this is talking about a RESTful resource. The resource is, the name is board, and its reference is using this handler. And with only these few lines, this is the result. When we access the board and message endpoint, instead of returning just the ID of the board, we get the full board that we defined before. This is super helpful to avoid doing more and more requests, because in just a single request, everything is done. And as you can see here, we have the self reference. It's a link to reference the entity you are viewing. This is because RESTful module, by default, implements the full JSON API standard. So let's see how we create some content. We just use, obviously, a post. We specify in the headers the access token. We post to the resource we created with the version the API version. If you avoid the API version, it will query the last version we have. And here is the content. We specify just the text, the description in this case, the board ID, and that's it. We get a full new entity created. Some questions so far? Any questions? No? OK. Before there was more content in this section, we talk about how do we validate all these queries, all these post updates, and so on. For that, there is a module called Entity Validator that follows exactly the same structure. It has like a CTools plugin that you define, and it will be called every time you work with one entity when you are doing modifications like a post or an update, a patch. And then there you can create your own validation rules to prevent, like, I don't know, SQL injections or whatever. So let's talk about the front end. When I talk about the front end, I say I work with Elm. Everybody says the same joke. Nightmare on Elm Street. Actually, it's totally the opposite. Elm is super fun, super cool, super friendly. So don't be afraid of it. How do you call an Elm developer? This is real. The Elm developers call themselves Elmos. For real, I don't believe it. Still I am a Drupal developer. So what is Elm? What is this Elm we are talking about? Elm is a purely functional language. That means it can be programmed only in a functional way. For example, JavaScript, PHP can be programmed in a functional way, but they are not purely functional because they allow other kinds of programming, like object-oriented, procedural, and so on and so on. It's created the purpose of this language is to create web browser-based graphical UIs. So it's only for creating websites. It doesn't work on the backend. It doesn't work for a desktop application unless you are using something to convert a site into a desktop application. It's compiled into JavaScript. People think that Elm is something like PureScript, TypeScript. That's not true at all, because those languages are based on JavaScript, and they just try to hide the big defects that JavaScript has. Elm is not like this. Elm is a language built from scratch. Their own syntax is completely different. The language is based on Haskell, and it's focused on usability, performance, and robustness. And it's also something called statically typed. Like JavaScript and PHP, they are not typed at all, but this is not like Java, where you have to specify the type. Here, the compiler, because we have a compiler, finds what type is the variable, and it will be that type forever. So if you change it at some point from an integer to a string, the compiler will stop you and return an error. So on the business side, how do we sell Elm to the client? So clients mostly pay for features. They don't pay for bugs. If there is a bug in your application, you have to fix it. And you usually are not getting paid for this. And most of the bugs that happen on a browser is because runtime exceptions. You have an object, you are trying to invoke a function of this object, and suddenly instead of an object, you receive null. And suddenly everything crashes. Elm prevents this in two ways. The errors are prevented on compilation stage before getting to the client. This means like most of the errors will be handled on the development time when you are working on the feature. It also handles it in a different way because in Elm, the null concept doesn't exist. there is a quote from the inventor of null concept, and he says something like, the null is my $1 billion mistake, something that we should avoid as much as possible. I will get into this more later. And for us developers, what comes with Elm? So Elm for me is a language super easy to test because all the functions are pure. This means that usually they are super small. The return value only depends on the input it receives. This means it's super easy to scale, super easy to cache, super easy to test. And it's a language it's very quick to develop with it. It's amazing. I've been doing Elm for 6 months, and I'm surprised every day of how much I've been able to achieve with Elm. When I started on the first application I received, on my first application with Elm, and when they told me what I was going to do, I was thinking, I have no idea how I'm going to be able to do this if I do it in JavaScript. And with Elm, in a few months, suddenly we have like a super complex full application wrote by only a few people and with no errors. And it's also a super fun language, super fun to work on. Very different to the other languages we are used to. I'm going to talk a bit about the Elm architecture. If anyone knows about Flux? No? Redux? Redux? Yes. So Redux is a JavaScript implementation of an architecture called Flux. The Elm architecture is more or less the same. Actually, Redux and Elm are every time copying themselves because both of them are evolving in different ways, and they are getting the good ideas from each side. So basically, the Elm architecture, or Flux, or Redux, or whatever you want to call it, it has like a model that represents the data we are showing, the data we are handling. We have a view to represent this model in a way that the user can see and understand. Then we have messages for the operations we want to do with our model. And then the last part is an update function that gets the messages and modifies the model based on the message it receives. This may be a bit complex. I'm going to explain you this same architecture in a very different way. This is the Elm architecture. You have a model, you have a view, and you have the messages you can do with the model, like turn around or run away, and then you have an update that changes the model based on the message it receives. This is it. There are other concepts that usually are part of all these kind of architectures, like immutable models, variables, and so on and so on. I'm not sure if that's important, so I will skip it. So let's start a bit with Elm. Let's start with the types we have. This is the rep, the interactive console. You have to play with it. So if you put a number and 1, it will tell you this is a number. If you put a dot, it will say a float. Number actually it can be a float or an integer. It doesn't know it yet. So until it doesn't know it, it will be just a number. Then we have characters, we have strings, we have lists, and we have something called records that are data structures that we will see later. We have more types, like booleans, like dictionaries, we will see later. There is also some concept of type on the Elm types that is called union types. So this is the definition of a boolean. Union type is a way to specify a variable that can have only a few values that you specify. So a boolean is a union type that has a false or a true, and that's it. If you put something else, it will fail because it's not here. Then we have something called maybes that is also a union type, and this is like the way Elm has to handle what in other languages is called a null. So if this value could be something else, it could be empty, it will get a nothing. If not, it's just something. We will see later how we handle it. But you can create your own types. For example, you can create a union type for Drupal roles. So you have the list of different roles you have, like anonymous, authenticated, admin, and so on, so on. And this is how you deal with union types. Every time you handle a variable that is a union type, you need to use a case. and a case that handles all the different options. And it always will return the same data value, because this is a typed language, that all the functions return always the same. So it's not like, OK, if this is false, I will return an error string, and if it's true, I will return an object. This doesn't work on Elm. So if there is an error, or if it's false, you have to handle it, and then return exactly the same type as before. So the application will never crash, because the null will never get out of this. It will be handled here, and it will be returned as a value that the program can deal with. This is the records I talked before. This is how we structure our data with more complex data, not only just a simple variable. So this is like a user. We have an ID that we create, and we say this is an integer. We also have a name that is a string. And that's it. Once you create it, you cannot modify it later on runtime. You cannot add a new value here, say email. That doesn't work. It will not compile. So if it's not defined at the very beginning, it will not work. So this is what immutable variables are. And this is how you create a function. You have the view user, that it receives a user, and it returns an HTML with something. This is an annotation. This is not actually required, but it's cool to have it so you understand what you are receiving and what you are returning. And then you have the function definition with the variable you receive, equals, and your code. This is how you create HTML with Elm. More or less, the functions will only have one line because it doesn't have returns. So what you put at the very beginning is what it will be returned. In this case, we are returning what diff returns. Diff is a function that receives two parameters, that is a list of attributes and a list of content. And more or less, that's it on Elm. So let's see some code, some real code on the Elm side. As I talked before, we are doing an application that is a chat room with boards and with board messages that belong to a board. We have seen how we have created the endpoints, the RESTful endpoints. Now we are going to see how we model this on the application. So this is our model. We have type alias board ID, that is just a string. And then we create the board, that is, it has an ID, a label, and a description. So here, instead of saying this ID is a string, we are saying this is a board ID. This is super useful because if you only specify a string, and suddenly on the code, you instead of sending a string, you send an integer, the compiler will say, OK, I was expecting a string, and I receive an integer. Something is wrong. But if you actually change the name and you say, this is a board ID, the compiler will say, I was expecting a board ID, and I receive an integer. And suddenly you say, I know what's going on. I know where the problem is. Then we have a dictionary of boards. Then we have the same as before, a board message ID that is just a string. And then we have the board message that is composed of an ID and a text. That's it. Questions so far? Just interrupt me at any time. Yes? A dictionary is a list that has an order. A list usually doesn't have an order, and a dictionary has. A dictionary has a key and a value. In this case, the dictionary is a board ID and then the board. A list doesn't have a key, only have a position that is actually not ordered. More questions? No? OK, so we need to understand what the RESTful endpoint is sending us. That is, this is a JSON file. So we need to decode it and convert it into a Elm object. This is a decoder for the board. So we are just looking for, in the JSON file, we are looking for something called ID. And we have a function that is decode ID. We are looking for something called a label. And we are decoding it with a function of a string. Description, the same. And exactly the same for a board message. And we have to do the opposite operation. We want to create a new board message. We need to encode it. This is exactly the same. We receive a board object, and then look for a board ID, pass it to an int function, and it will be assigned to an ID label on JSON. Quite simple so far. Those are the messages we are doing with our application this time. A lot of them may be noise for you, but so we fetch the list of board messages from a board ID. Once they are fetched, we have to handle what it returns. So a board or a board dictionary or a board message. We also update messages. We send messages to the backend and update boards and send them to the backend. That's what we are doing. And then we have our view that is something like this. We have the view that receives our model and just creates a div with another div. And inside this div, we view all the boards available, and then we view the board that is active right now. So we are only seeing the messages from the specific board. And then we have two specific functions to do this, like view boards and then view boards and so on, and the messages and so on. And this is how it looks. And that's it. You have an application. You have the different boards, and then you have the content of the chat room. This image actually is taken from the demo during the workshop. So this was people inside the session writing messages live. And as I said, we need an update component. This update receives the message, the model, and covers all the cases of all the possible messages. And we handle it, and we always return the same, a model, an updated model. This is just, so we are handling the fetched boards. If it's OK, we receive a new dictionary of boards that we assign to the existing boards and return it. And if there is an error, we will handle it in a different way. We probably will just have a variable on the model saying errors that we will display on the screen or whatever we want to do with it. So let's move on to the real-time notifications. Before talking about real-time notifications, we have to talk about communication. There are two ways of communication. The first one is called one-way direction communication. This is like HTTP, or like an email. You send an email, and then someone will reply or not at some point. And then we have the bidirectional, like it's a phone call. You are talking, but the other person can interrupt you at any moment. So when we are dealing with real-time notifications, we want to be able to communicate with the server and the client super quickly at any point. Even if the client is sending a message to the server may want to send a message to the client. So for this, we have something called WebSockets. WebSockets is a communication protocol that connects the server and a client and allows a stream of data regularly. We didn't want to implement like a full implementation of sockets in PHP and in Elm and so on and so on. So we decided to give a try to a service called Pusher. Pusher is a third-party service that allows us to handle all the WebSockets. We only just push some data to them, and they do the broadcast to all the clients, and also gave us a JavaScript client library that we implement and update us when something is received. And this is how we implement it on the backend. On our classes from before, on the RESTful classes, we add a function called create entity. So when we do a post, the create entity function will be called. We just do the parent create entity because we don't want to do anything else with it. And then we push to Pusher. This just has some values like operation that will create an event and the data we want to send, and that's it. So that's what we get. We do a post, and then on the Pusher interface, we see that we have received this message with this content. That is the new board or new board message that we have created. And it's all broadcasted to all the clients connected to this channel. And then we have to implement it on the front end. So we have different Pusher events. You can ignore this one because it's for a different example. And then we have the event names. So this is, again, an union type. And as you can see, we specify what we are receiving, and we get the actual value. We decode the message. So depending on what kind of message we are receiving, we are calling a different decoding function to convert the JSON we receive from the message into an object. We handle the different events. So here we get the message. We are sending a new message. So once it's received, we just add it to the dictionary of messages we have and update the model with it. And if it fails, we just return the model without updating. We are not handling the error, but we could, perfectly cool here. So every time we are handling or touching a union type, always you have to handle all the options, always. So no crashes. And then this is a subscription. This means when the user gets online, loads the page, it will get subscriptions to different things. Like in this case, we want just to subscribe to the pusher channel that handles the board messages that is here. So that means that the user will be listening all the time to all the petitions received from pusher. But as I said before, pusher give us a JavaScript library, and Elm is not JavaScript, so we need a way to communicate with JavaScript. But this usually means that we have a problem, because with JavaScript we don't have the type safety that we have on Elm. For that reason, we use a pattern called ports and adapters that you may hear about. So we define a port. That is, we actually are just defining a function that is called pusher board messages that will receive a function and it will return another value. But we don't implement it, because when we specify this is a port, we know we will have a JavaScript file that handles it, and it will have a function that does this, receives this, and returns it. So if the JavaScript doesn't work and something fails in the middle, Elm will not get it. This function will not get called, and we will be protected. The user will lose data. That's true, but the application will not crash, and it will continue working perfectly. And this is the implementation of the port on JavaScript. This is the only JavaScript we have. So only just adding a single line for handling the event. And I will show you the demo of what all this code is all about. Hopefully it works. So this is the page we just built. We have here the different boards we created. When we click on one, we send a message saying we are selecting this specific board. And when we do so, we get the different messages on this board. As you can see, there is a small delay because first activates the board and then does a query to the backend saying, I want all the messages in this board, and then it loads the messages. I will switch to a different channel so you can see it. This one was quick. Yep. Oh. Well, that's quick. And we can create new boards. And there we go. If I select it, it will be empty at some point. Maybe the communication is not working correctly. But anyways, if I give you the URL of this site, you could actually see the chat rooms. You could select one chat room, write on it, and it will appear here on live time. And I want to show you something else very cool about Elm that we have here in this corner here. This is, as I said before, the model doesn't change. It's immutable. It will always have the same attributes, always. Even if we change the values of those attributes, the structure will be the same. And what we are doing every time we do an update, we are creating a new copy of the model with just some few changes. And this keeps stored on the memory. So when we are on dev mode, we can go back in time and see what we are doing, all the changes of the model. So if I go to the very beginning, when we load the page, the page will be empty. Then sends the query to load the messages, and here has received the messages, and we can go back, and we select a first board. So this is really, really useful, because if you have someone doing QA, he's testing the application, and he says, there is an error here, something's wrong. It can just export these changes on the model, send it to the developer can import the changes in the model, and reproduce the exact error the other person had. So you don't have like vague reports like, this page doesn't work. You have a full export of all the changes they have done, and you can reproduce it really easily. Not only that, but you can integrate it with your CI environment, so if it executes the test and something fails, you can export this history and upload it to your issue, and you can reproduce the error. As I say, this is a language built mostly for developers. So, want to see more about this, about Elm, about what we do at Gizra? If you go to this page, this is the skeleton we use for creating Drupal applications with Elm on the front. It's super cool, has a lot of really interesting features that you can have for yourself. This is totally open source, you can use it. And also, just find me around, I will be happy to show you more about what we do or how we do it. That's all, folks. More questions? Yes, there's a question over there. Wait a second for the mic. Over there.
Thanks for sharing. It's quite enlightening talk. We have some confusion from our ignorance in the new approach to RESTful API. How do WebSockets and RESTful underneath relate to each other?
Okay, so on one side we have the RESTful endpoints that we query normally, like when requesting things. The sockets, you use it to when the backend wants to send information. And what we are doing is just in the programmatically calling the same RESTful resource we are using for the service, and we just send this to pusher. So we are actually just doing like initializing the RESTful class, unloading the node, and just push it to pusher.
So is it kind that you have a WebSocket established with pusher?
Yes, pusher, what it does is gives you the WebSockets magically without you doing anything.
And then the RESTful goes on top of?
And when we send the data to pusher, so pusher sends it to the WebSockets connected with them, we send the content generated by RESTful. Yes.
Okay, thanks.
More questions? Yes? So, yeah, the original workshop had full sections about what happens with Drupal 8. I'm not really into this part. I haven't done that much in Drupal 8 yet. We are waiting for mostly JSON API to be ready, and also to GraphQL, maybe another options. We have more hopes on JSON API because it's more similar to what we use already. Right now, the problem with JSON API is requires too much effort to write endpoints. And not only that, it gives you a lot of endpoints by default that you have. If you don't want to expose them because you don't need them, you have to manually hide them or change it, and so on and so on. And I think also we had some problems with authentication with JSON API. Not really sure. I'm not into that too much. More questions? Okay, so as I have like 5 minutes, you may be asking yourself, what can I do with Elm? I will show you the application we are building at Gizra right now. So this is a tool that we are creating for teachers to use in schools. So basically, the idea is every student will have a computer with them, and the teacher will have a projector and their own computer to do more or less the same. So we log in as a teacher. I think the internet doesn't work really well. And we have a list of subjects, and each subject we have a list of lessons that we can modify. For example, like this one, we can edit it. This is an interface similar to PowerPoint, maybe. So you can put videos from YouTube, you can upload images, you can draw on it. And then once your session, well, you can add like more slides, you can have like quizzes with questions and so on and so on. And then once the teacher is happy with it, can launch a live session. It also imports like PowerPoints and more things. And this here gives a join code that each student will put on their computer, and suddenly everybody will be seeing the same. And then when the teacher changes the slide, it will change in all the screens of the teacher, of the students, and then when it starts the quiz, all the students will only see the quiz that they have to reply. And not only that, the teacher will be seeing on lifetime all the questions, all the students, what they are answering. Actually, I can show you if I log in as a student. So you see the lesson ID, we put the code we have there, 9212. So as the quiz has already started, the only thing the students see is the quiz. And if I reply, I will see on the teacher screen that he has failed or he has done it correctly, and then move to the next question. And then I end the quiz, and the student will see the results of the quiz, what he has done correctly, what's wrong. Not only that, but at any point, if I change the slide, it will change on the student slide also. The student, it's not seen here, can send questions to the teacher. Hello. So the teacher has now a notification here, and we'll have a question over there from the student. As a teacher, I can also see the screens of each student. I can jump in, see what's doing. I can take control of their screen. I can add annotations to this specific student that only the student will see. And all of this is Elm and Drupal.